Hi, I am Vikramathithan. I am going to discuss with you about signals and systems. Let us start some basic introductions about signals. Now, what is the difference between a traffic light and a traffic signal? Let us say traffic light. Three colors in traffic: red, green, and orange. Why you say it is traffic signal? Why not a light? Because it gives you some information. For example, if it is red color, you are going to say stop. If it is green color, it's going to say go. Now you are getting some information from that particular light. So you call it as a traffic signal, not as a light. Whereas if you just take an ordinary bulb, which is a white color light or yellow light, you say it is just a light. There is no information in that. So what is the conclusion? Signal is a content which has some information. So basically, what is a signal? It should gives you some information. Okay. Such signals we are going to classify into some categories. One is continuous, and discrete signal, and number two, periodic and non-periodic signal. Number three, even and odd signal. Number four, energy and power signal. Number five, deterministic and random signal. Number six, real and complex signal. We categorize the signal which conveys the information into 6 categories. So one by one we are going to discuss, and we are going to do some problems in each and every types. Let us come to continuous and discrete signal. I am just talking to you. My voice is an amplitude. Let us say y-axis, amplitude. I just started my lecture just 1 or 2 minutes before is with respect to time axis. Now I am going to represent my voice, which is the amplitude, which is my sound level with respect to the time. My voice is sometimes increasing and sometimes decreasing, sometimes increasing, like this. Can I say my voice is available at every instant of time? Yes, of course. That is the reason we call it as continuous signal. Now let us define a continuous signal. Signal which has amplitude at every instant of time is said to be continuous signal. Then what about discrete signal? Let us redefine. There is a signal. Let us have the same time axis, and that is the same amplitude axis. It will have amplitude not at all time, only at particular instant, which means, let us say a stock market, let us say your marks in your examinations, let us assume your marks itself. Every month there will be a test for you, maybe internal assessment. For the first internal assessment, you scored some marks, let us say A. After 1 month, second internal assessment, you scored some other mark, let us say B. Now I am going to just plot. At first internals, there is a marks, and at second internals, there is a B marks. At third internals, let us say C marks. Yes, even this is also a signal. It gives you some information. Conclusion. This signal is having amplitudes not at every place, only at some particular instant. So we call it as discrete signal. This is my voice having amplitude at every place. So we call it as continuous signals. Let us define. Signal which has amplitude at every instant of time is said to be continuous signal. Signal which has amplitude at particular instant of time is said to be discrete signal. Just if you want, you can make a note. Just a simple introduction. What is the second one we discussed? Periodic and non-periodic or aperiodic. I told amplitude and I told there is a time. Every time we can't keep on say time. Let us mention with a simple symbol T. Every time I can't say amplitude, let us mention with a simple symbol X. Please recall, this is my time axis, this is my amplitude axis. My voice depends on my time. 10 minutes back, my voice is not there with respect to time. So my voice is a function of time. In a simple fashion, I can't control my time, but I can control my amplitude. Repeating, I can't control my time. Time is independent. I can control my amplitude. Amplitude is a dependent and it depends on time. So you should not represent as x. It depends on time. Let us say x of t. Recall your marks in the test. This is your marks. Can you have control on your test? You can't say to your teacher, don't do test tomorrow. You can't say. But you do have control on your marks. You read well, you score marks. So your marks is dependent. It is in your control. Test is independent, not in your control. So we say marks is a function of test. Amplitude is a function of time. In general, amplitude is a function of time. So you should not mention as x. You should mention as x of t. Sir, what I should do, sir? For discrete, same time, but there should be a difference, you know. So what I say for discrete, it is n, it is x of n. Recall the whole story, continuous and discrete. Now let us back to the new concept, which is periodic and non-periodic signal. Now I am going to give two different graphs. T stands for continuous, N stands for discrete. Have a look on this. Have a look on this. Just to give a generalized statement. Have a look on this. Do you feel, is it not repeating? Yes. It is repeating at a given interval of time. A signal whose amplitude 5 volt repeats at regular interval of time is said to be periodic signal. Is it repeating? No. Then it is a non-periodic signal. Redefine. A signal whose amplitude is repeating at regular interval of time. Now let us say the interval here is that gap, which is say t. There is no such interval here. That is the reason we call it as a periodic signal. What are the definitions, sir? Amplitude at a given time will be same as after one duration, after two duration, after three duration, after t. So let us say amplitude plus t, t plus t. Amplitude at a given time is same as amplitude at the same time after a time period t. This is the definition of periodicity. Will it applicable here? No chance. Then what I should write here? Can I write the same? No, not equal to. Sir, this is for continuous. Is it holds good for discrete? Definitely yes. X of n, I told t for continuous, n for discrete, is same as x of n plus, let us use the same type of symbol, n. Continuous time, discrete time. Continuous time period t, discrete time period n. But what about here? Same, not equal to. If you want, I can just show one discrete signal. N, x of n. 2 volt, 5 volt. 2 volt, 5 volt. 2 volt, 5 volt. It's repeated. 0, 1, 2, 3, 4. Yes, it is periodic, which is a discrete periodic signal. So this is comes under this category. So let us recall. This is the basic definition of periodicity, and this capital T is nothing but time period. Same, this is the definition of periodicity for discrete signal. This capital N is also representation of time period. This is continuous time period and this is discrete time period.